So in this particular problem, we have a submarine that is located at a distance of about 850 meters below the surface of the water. Okay, if I'm drawing this to some sort of scale, there's my best looking submarine. Has a circular hatch on the top, and we want to know what the net force is exerted on this particular hatch. This is going to be a combination of two problems. First, the general definition of pressure being force over area. Secondly, we're going to have to utilize that the absolute pressure is equal to the atmospheric pressure plus the density of the liquid that the object's immersed in times the acceleration of gravity times the depth or height for which this object is placed. Now, we know this is 850 meters is the distance. We know the atmospheric pressure, I'm calling PO, of 1.01 times 10 to the fifth. For some reason this isn't coming through. Pascals. And then we know, the density of water being 1,025 kilograms per cubic meter. So now, two steps. Our first step is going to be figure out, well, just exactly what is the absolute pressure due to the water and atmosphere on the top of this, because that will be exerting a downward force. Then what we need to figure out is what the interior upward pressure will be on this door as a result of the cabin pressure in there. The difference between those forces will be the net force, and we're told the area, or the radius rather, of the hatch itself is 0.4 meters. So step one, use this equation right here. Step two is going to be, using the known cabin pressure and solving for the area, the surface area of the hatch, what force is exerted on that system. Okay, so let's go ahead and give it a go. So I'm going to use this equation first to find the absolute pressure. So absolute pressure equals 1.01 times 10 to the fifth. I don't know why this is a bit of a delay here. 1.01 times 10 to the fifth, that is the absolute pressure equals the atmospheric pressure, which is this, plus the density of the salt water, which is 1,025. Times 9.81 times the depth of the water, and then doing a quick calculation, we find that the absolute pressure exerted on the top of the door, as we'll call it, as a result of the atmosphere and the water, is 8.648, we'll call it. The reason I'm going with so many digits is I don't want to lose some of my precision for the sake of making sure I have an answer that's reasonable. Times 10 to the, what do we got, 2, 4, 6, times 10 to the 6th power. And that, if we're sticking with units, that's pascals. Again, that's not our final answer. That is just an intermediate answer we need. Our next step now is to use this equation here to figure out, well, no, we're not doing that just yet. What we're going to do now is we're going to figure out what the net difference in pressure is. Once we have the net difference in pressure, using then this equation here, P equals F over A, we can find the net force on the hatch. So if we take the net pressure, P net, equals the P absolute minus P sub, pressure in the submarine, that will give us the value we're looking for. So if I subtract off the, what is it, 1.25 to the fifth power, I end up with a value of 8.5229 times 10 to the 246 power. This is the pressure, the net pressure. I want the net force, so net pressure equals net force over the area, or in rearranging, I say pressure times area gives me force. So 8.5229 times 10 to the 6th times the area. The area of this thing, we know the door has a radius of 0.4 meters, so it's kind of like circular. Pi times 0.4 squared. And then in doing a quick math computation, we find that the force, the net force, exerted by the atmosphere on the hatch, and the difference between these things at this depth is going to be 4.282, we'll call it, times 10 to the 4 times 10 to the 6 power newtons. So that's the net force, the difference in the forces between those two objects.